Hi everyone, thanks for joining the session. So now I'm going to discuss about Traceroute. Okay, so Traceroute is similar to ping. So if you initiate a ping, right, it will start sending IP echo, ICMP echo request packet, and you'll get a reply. So it will check the reachability, whether we are reaching the destination or not. You will get to know the round trip time value also. What is the latency, and right, you will come to know latency and whether you are able to reach the IP address, destination IP address or not. So Traceroute is more advanced, like so from source to the destination, how many routers in between? Okay, suppose there is a problem on R2, so maybe some link went down, G1/0. So how you will come to know? You cannot go you cannot log in the router and you cannot see it. So you cannot troubleshoot it right directly. So using Traceroute tool, so if you initiate a Traceroute right to the destination, in that path it will check on each and every hop, and in case if any fiber cut or any cable cut, right, it will packet will drop on R2 router, so that you will come to know, hey, there is a packet loss on R2 router, so that something fishy, something, there is a issue on R2 router. You can tell to the field team and you can troubleshoot it accordingly. This is how you troubleshoot in real time. Okay, so let's see how Traceroute works. See, I'm giving a Traceroute command. What is the destination Google IP I'm giving? See, if I'm initiating a Traceroute from R5 router, so it will tell you how many routers in between. So first router is 45.4. It means this one. 45.4 is this G1/0 interface. Okay, this router IP address. And next one is 24.2 is R2 routers. R2 router G2/0. Okay, and next one is 12.1 is ASBR router R12, right, 12.1, this one router. And next 18.8 is this IP router, Google Google interface IP address router. So the thing is, how exactly these IP addresses are displaying here? How, what is the background mechanism? Okay, I understood now. Once I initiate a Traceroute, it will send a packets and I'll come to know this is a round trip time. Why it is this round trip time is showing 3 times? And how exactly we are able to see the router IP addresses here? What is the background process? Okay, it's very interesting. Would you like to know? Can I explain? Shall we start explaining? Hello.
Yes, sir.
Okay, fine.
Yes, bro.
So how Traceroute works? Okay, Traceroute is a Linux command, and in Windows we use Traceroute. Traceroute same 8.8.8. So Traceroute and Traceroute both are same commands, but the process is, this is Windows command, this is Linux command. In Windows, the packets are different. So let me explain you how exactly. So even I'm just showing the rough example. See, first I'm real time I'm doing Google Traceroute here. So first it is going to my Wi-Fi router, then it is going to ISP router, then there are multiple routers in between them. Up to 30 hops. Up to 30 hops it will check. So what is the maximum hops it will display? Up to 30. Okay. Yeah. Now let's see the process. Okay. Now, do you know TTL value in IP header? Everyone?
Time to leave, sir.
Yeah. Does everyone knows, or shall I explain TTL value?
Explain.
Okay. I will explain TTL value. Before that, see, it's a IP packet. Okay. In IP packet, this IP header, right? There is a TTL value here. What is the TTL value here? Time to live. So the TTL value will be varies from 1 to 255. Okay. So 255 is the maximum count. What is TTL value? Time to live. So time to live in the sense it has expiry. Okay. I'll tell you how exactly it works. But where you will see the TTL value, I'm showing here. I showed here. Where you will see the TTL value? Where you will see the TTL value? Which packet header you will see the TTL value?
The ping, sir. Sir.
IP.
IP header
IP,
now.
IP,
So
right,
what are the
sorry.
important fields in IP header? Source IP address, destination IP address, and the TTL value, protocol number. So far, protocol number will learn, source IP address, destination IP address will learn, and now today I'm going to discuss about TTL value. Very important. Okay, let's discuss about TTL value. So why TTL is important is, in IP routing environment, if there is any loop, okay, suppose there is a packet, okay, let's say some packet. IP packet, IP packet. Okay, it is R2 is sending IP packet to R1. Again, it is sending packet to R3. There is some connection between them. So just like that, like this, you can see. Okay. Okay. Now there is a connection between R2 and R3. Okay. So this is the IP packet. Okay. This IP packet will go to R1, R1 to R3, R3 to R1. So this IP packet is, sending like this sometimes. So there is a chances for looping. So there's a big problem, right? In any technology, I told you, what is the biggest problem? Loops. Either switching technologies or routing technologies,
Broadcast.
the problems are loops. So you can see the broadcast packets and broadcast frames as well. So loops, how loops will occur? You're sending a packet to the router. This router same packet it is sending to R3. R3 same packet is sending to R1. It means whatever the packet you are sending out, right, you are receiving again. It means if you enter in the ring road, right, you start journey on the ring road, and you travel across the ring road, and you will reach where exactly you entered, right? That's called loop. It means the packets which I'm sending outside, right, same packets are reaching out to me by from another router. That's called loop. Okay, so the loop will create like this. If the loop continuously will create, right, the interface utilizations will increase, the router CPU will increase. If any packets comes, right, hacker will try to ping you. So currently we are pinging just 5 packets, 4 packets. The Windows is pinging just 5 packets. See, ping 8.8.8.8. So it will send only 4 packets. So the router, the server, Google server will respond with only 4 packets reply. It will come reply it. So what if you send 1,000 packets? What if you send 1,000,000 packets? All million packets you need to respond, right? If you want to respond, see, if there are 4 members, they're asking doubt to me, I can respond it. If again 1,000 people asking the same doubt, how can I explain to 1,000 people? Different doubts maybe. So I cannot explain, right? So there will be a burden on me. Similarly, there will be a burden on server. Okay, so that is called DDoS effect, distributional denial of services. You know what? The hackers will generate a broadcast packets trying to stop the service by making busy of these CPUs, by increasing the CPU highs. They increase the CPU to threshold higher level, and there is a burden on the CPU. The router will not respond it. So there is a big problem in your network. So to stop that, there is a TTL value in IP header. Okay, so every router, right, R2 to R1, R1 to R3, like it will circulate like this, and it will create a loop, and your entire network, these routers will be hung state. It will go to the hung state. These routers will not responsive. It will go to the unresponsive state, so that your entire network will be down. So to stop that loops, right, in IP packet we
Yes,
will have a TTL value. TTL value 255. So the thing is, if if R R2 router sending IP packet to R1, okay, R1 router, what it will do, it will reduce the TTL value by 1 to 255 minus 1. Okay, while sending R2 packet to R1, it will reduce the TTL value of 1, and now one hop is crossed, right? Now it is 254. Okay, now the TTL value is 254. Same thing. Now R1 sends a packet to R3. Okay, before sending, it will reduce the TTL value of 1. Now 255, 254 minus 1, how much? It is 253. Okay, like that the packet will travel to here, and it will reduce to 254. Like that, till how many times it will packet will travel? Up to 255 times, right? So the thing is, TTL value will be reduced by 1 after crossing the each hop, each router. So it will circulate up to 255 times only. Then when finally the TTL value will become 0, right? The TTL packet will become 0. Once the TTL value is 0, it will generate error. Hey, the packet is expired. I cannot send the packet to out. It will generate a error called ICMP error, type 11 code 3. Okay, it will generate a ICMP error message. Hey, the packet is expired. Okay, so that you will avoid the loops by using TTL values. Understood what is the TTL value, how it will avoid? This is a scenario based question. Okay, so how TTL value avoids the loops in IP routing? So but it will generate a TTL value of some value. When it is crossing the router, right, it will reduce the value by -1 so that it will become to 0. The TTL value will become 0 at the after 255 times. The TTL value becomes 0. Once it is 0, the packet will be expired and it cannot process the packet further, so that all the routers will be the they can perform well, because there is no packets coming in, right? So they will be relaxed to so if there is no packets coming in, they will not process anything, right? Guys, are you understanding the importance of TTL value? Anyone having any
Yes,
questions
sir.
on TTL?
No, sir.
Okay, one field I'm explaining about one field with real-time scenario. Okay, now why TTL value comes into the picture in Traceroute? Listen. So I'm on R5 router. Okay, listen carefully. I'm on R5 router. I'm giving Traceroute. What is the Traceroute? 8.8.8.8. Okay, so it will generate a packets, IP packet. Okay, it will generate a packet source IP. What is the source IP here in R5? Can you please tell me? I'm giving a Traceroute 8.8.8, right? What will be the source IP in R5? So this is
5
the
dot 5 dot 5 dot 5.
no, man. Why 5.5.5, brother?
1/0.
Interface IP will be.
Very good. Interface IP. It will be interface IP, exit interface IP. The packet will
అంటే
always
IP
take the exit interface IP. Why are you saying
ఎస్ సార్
5.5.5? It's a loopback IP. It
అంటే
will not take. What is that?
అంటే ఐపీ లేదని నేను 5.5 చేశాను.
No, IP undi, but I didn't mention it here. I told you, right, how to design a lab. So what is the
ఓకే
network
సార్.
here? What is the network here?
ఎస్ సార్.
192.168.45.0. Okay, /24.
ఓకే
Okay,
సార్.
it's a 45.0 network, right? I told you how to design a topology. It's a 45.45. So in G1/0 it is 45.5. Here it is 45.4. Okay, similarly R2 and R4 it is a 24.0 network, like that. You know, right, how to design a network. Okay, it's the
ఎస్
same
సార్.
thing. Okay, now what is the source IP here? 192.168.45.5.
92.168.45.1 సార్.
45.5.
Yeah, I'm taking 40.5. What is the destination IP?
8.8.8.
Yeah, perfect. Destination IP is 8.8.8. Now, in the IP header only, what is the TTL value here?
It's a 255.
255.
No, no. Traceroute use TTL value 1 only. Okay. So, traceroute use TTL value of 1. So, once you initiate a traceroute use UDP packets. Okay. It use UDP packets. It will generate, initially it will generate 3 UDP packets. Why it will generate 3 UDP packets? Because during transit, even if any packet will lost, right, it will other packet will get response. Okay, so the thing is traceroute use UDP packets, but the process is same. The trace at Windows command use ICMP packets. So the packets protocol is different, but the process is same. So traceroute use UDP packets, traceat use ICMP packets. That's it. Now if you see here, right, once I initiated a traceroute generate 3 UDP packets with the TTL value of 1. Okay, traceroute generates UDP packets with the TTL value of 1 and it will send to R4. Now R4 will check the destination IP address is 8.8.8. To reach 8.8.8, we need to reach R2. So it needs to send the packet to R2. But before sending the packet, it will reduce the TTL value -1, right? Now it became 0. Okay, the TTL value, it will reduce the TTL value by 1 and the TTL value became 0, so that the packet will not process further to R2. So what R4 will generate? R4 will generate a ICMP error. What is ICMP error? Type 11 code 0. Okay, type 11 code 0 is the ICMP error, stating that TTL value is exceeded. TTL is exceeded in transit. It means while traveling to 8.8.8, the TTL value is exceeded. So who will generate this error? Who will generate this error? Where the TTL is expired, on which router?
R4, sir.
R4.
So R4 will generate a error. So now what is the source IP? It's a TTL, right? It's a ICMP error, ICMP packet. It has a source. Yeah, what is the interface IP? Exit interface IP, right? What is IP here?
192.168.45.4.
45.4. Very good. 45.4. And the destination IP is 192.168.45.5. Now, this error packet will generate and send to R5. R5 will receive it. Hey, the TTL value is exceeded. Okay, fine. What R5 will do? Okay, I will generate it 3 UDP packets again with the TTL value of 2. It will generate a again it will generate a 3 UDP packets with the TTL value of 2. But the thing is, before sending out this packet to R2, it receives a code, right? Immediately what it will do? It will display here. If you see, right, this 45.4 will be display here because the error is coming from 45.4. So that's why, okay, 45.4 is the next hop, and this hop is telling that ICMP error is generated and TTL value is exceeded. Okay, now understood, right? How exactly the hop value is displaying here based on the ICMP error packet. This ICMP error packet is generated by R4 router and is sending a packet to R5, and then R5 sees it and it will display 45.4. Hey, the next hop router is 45.4. So yeah, so that's how it will learn the hops. How many hops in between source to destination. Now see, this UDP packets will go to R4. It will do the route lookup and it will reduce the value TTL value by 1, and now it is 1, it's not 0, right? So that the packet will go to R2. Now R2 will check the 8.8.8. To reach 8.8.8 I need to go to the R1 router. So what it will do, it will reduce the TTL value by 1, right? Now here it became 0. Okay, now R2 what it will do, it will generate a ICMP error packet. Now tell me what is the source IP here? R2 will generate a ICMP error, right? Now what R2 will generate a ICMP error packet. Now what is the source IP here? 192.168.
Two.
Sorry?
45.5.
No, it's between 24, right?
24.2.
Yeah, it's 24.2. Okay. So this IP address, R2 exit interface IP address is G2 class 0. So it's a 12.0 network. Sorry, 24.0 network. 24.0 network. Okay. So 24.2 is the IP address. It will generate to 45.5. That's how this router will come to know 24.2. Okay. Now again what it will do, okay, again the packet is expired, let me generate. So until it reaches, right, it will generate a TTL value of 3. Same again, packet will go to R1. Okay, R1, it will reach R1. Again R1 side TTL value will be expired, so R1 will generate ICMP error code with the source IP address is 12.2 now, 12.1 now. So that's why 12.1 will be displayed here. So now finally it will generate again 3 UDP packets with TTL value of 4. Okay, and now the packet will go here and again it will go here. Okay, so till it reach Google, right, the TTL value is 1, so that nothing will expire here. So the Google router will check destination IP address is my IP address, so that it will give you a response. What is the response now? What is the response now? Type 3 ICMP, type 3,
Type 3
code
code
3, code 3,
Codes.
code 3. So what do you mean by type 3? It says port and destination unreachable,
destination 100.
uh, port unreachable. So port unreachable. Okay, so see, we are checking layer 3 connectivity, right? So that's why, so layer 3 it is okay, but port is UDP uses port, right? Random ports, it uses random ports, 34,000 something. So we are not checking any service, that's why it is showing as a port unreachable. So we are only checking the layer 3 connectivity. If layer 3 is perfectly fine, then only it will go to the layer 4. So in layer 4 it is going and it is saying that port unreachable, it means layer 3 is reached. That's why Nageshwar Rao, you are getting a error. That is not an error.
Yes,
That is
sir.
a successfully completion of the thing. Okay. So it is saying
Okay.
that layer 3 is reachable, layer 4 is not reachable. We are not checking layer 4, right? That's why port is unreachable. If it is showing the port unreachable means it is successfully reached. Can we check the packet capture, whatever we have discussed now?
Yes.
Yeah, this is a packet capture. So we have done trace route, right? Yeah, if you see, right, trace route, this is a trace route output. Okay, so first where I have done, I'm on R5 router 45.5. So first, once I initiate a trace route, it will generate a 3 UDP packets, 1 2 3. So 1 2 3. So first packet it will generate, what is the TTL value of first packet? 1, right? Are you checking it? And the source, what is the port numbers it will use? UDP port numbers, it will always use 33,434 to 33,535 something. So I have described the trace route in a very well manner. Please download the PPT from our website and check this. It's a very beautiful PPT. See, I have taken a 4 routers. Okay, so trace route is used to check the reachability, round trip time. Okay, up to 30 hops it will use. The ports, right? The result ports are 33,434 to 33,523. Are you seeing this? These are the ports, reserved ports for Traceroute UDP. Okay, same thing you are seeing in packet capture here. See, the 434, it is using 33,434, right? Yeah, 33,434. It will start from that destination port. Source port will be always random. Okay, yeah. Okay, so now if you see, right, it will generate a 3 UDP packets. This is the first packet with the TTL value of 1. This is the second packet with the TTL value of 1. And this is the third packet with the TTL value of 1. First, it will generate a 3 UDP packets. Okay, first packet is generated with the TTL value of 1. And now if you see, right, 45.4 is responding, hey, TTL exceeded. Time to leave existed in transit. So what is the code? Type 11 code 0. They will ask in interview. Type 11 code 0. Okay, very important, guys. Prepare well about the trace route. So it will generate a error code type 11 code 0, and you will come to know the next of value 45 dot. Who is generating this code? So who is generating the source IP is 45.5. This is generating. Okay, so yeah, 45.4 is generating actually. So this is it. Source address is 45.4 is generating. Okay, yeah. So this is the error code. Okay, similarly you will see same code. So with the TTL value of title is exceeded. It is generated 3 UDP packets, right? 3 errors you will see. Once upon sending 3 UDP packets, this is the fourth packet. See, 1, 2, 3. It is done. First 3 UDP packets is done. And now it is sending second 3 UDP packets. See, now with the TTL value of 2. With the TTL value of 2. Okay. Now this is second set of 3 UDP. Now this is third set of 3 UDPs. It is sending the TTL value of 3. Okay, now and the final one is this one. It will send the TTL value of 4. Okay, once the packet is reached, right, it will send type 3 code 3 value. So this is a, see, this is the ICMP packet, ICMP code type 3 code 3, destination unreachable, port unreachable. It means the trace route is succeeded, as the trace route is went well successfully. Okay, yeah. So type 3 code 3. So this is a packet capture, guys. మీరు కూడా trace route చేసి, yeah, just please explore everything. Please do trace route and do packet capture and analyze the each and every packet like how I show you here. Okay, so
Oh,
this is it.
okay.
Okay, this is very simple. Prepare well. This document describes very well about trace route. Okay, in simple manner, just 4 slides. Prepare well. Okay, or else just watch this video one more time and prepare well about trace route. That's all about trace route. Any questions on trace route?
సార్
Yeah, please.
సార్ ఇప్పుడు మనం ట్రేస్ అవుట్ చేసినప్పుడు స్టార్స్ వస్తుంది కదా సార్, దాని మీనింగ్ ఏంటి?
Yeah, that means that there is no route to reach the destination. Okay, it's a very good question. See, this is a packet, right? It will generate a packet to trace 8.8.8, and now see, I'm on R2 router. In R2 router, there is no route to reach 8.8.8. It means it will show you star. So can we replicate it now? So let's do that. So I'm on R2 router. So I'm on R2 router. Config terminal. The interface G 2/0. I'm going to shut down this path. So let's shut down this 2/0. Now do trace route on R5. So now I'm doing trace route. See, 45.4 it is going, but R2 it is star star star. It means there is no path to reach the destination. Is it clear? So I'm on R2. I'm on R2, right? Sorry,
Yes,
I'm on R4. Here, where am I? I'm on R4. Here I don't have route to reach the destination. See, now it's down, right? Show IP route. Do you have route to reach the 8.8.8? 8.8.8 route is there, but it will be there for sometimes. Now it will not there. The OSPF is expired, right? Show IP route. See, all the routes are lost. Okay, 8.8.8 is not there. If there is no route to reach the, there is no route for the destination. There is no destination route in routing table. What it, how it will, why it, so how it will show you? It will show you star star star. It represents there may be a two things. One is there is no route in your routing table. Maybe UDP may be blocked. So the trace route uses UDP, right? So UDP ports 33,434. That port may be blocked. These are the two scenarios. Okay, is it clear?
సార్
Yeah.
సార్ ఆ పోర్ట్ అనేబుల్ చేసుకోవాలంటే అంటే
What do you mean by enable?
అంటే ఇప్పుడు మీరు పోర్ట్ డిజేబుల్ అయ్యి ఉండొచ్చు అన్నారు సార్.
పోర్ట్ డిసేబుల్ అనే ఎనేబుల్ ఉండదు. పోర్ట్ బ్లాక్ ఉంటుంది. సో పోర్ట్ బ్లాక్ చేసేది ఎవరు? ద పోర్ట్ మే బి బ్లాక్డ్ బై ద అడ్మిన్ ఆఫ్ దిస్ రౌటర్. ఓకే, సో ఇఫ్ యూ వాంట్, see, you can just tell them you don't have access, right? You don't have access to configure something on these other customer routers. Okay, you can just tell them, hey, this port is blocked, check with them, with the team, so they will allow you. So that is it, that they will block the port by using route maps and ACLs. Okay, access control list. By using ACLs, they will block the ports. So there is a ACL concept. I will explain you in BGP class. Okay, so IP
ఓకే
header and IP header, TCP header, there are fields, right? Source IP, destination IP, source port, destination ports. Based on these fields, you can block the services. Okay, by using ACLs. That is different story. Okay, yeah. Fine. So this is all about Traceroute. Any questions?
సార్
Okay, fine. I'm stopping the recording now. Thank you.